Welcome back, guys, to another video on the energy units. In this particular lesson, we are going to cover phase diagrams. So in a previous video, we covered heating and cooling curves, and it was important to cover that information because it represented the relationship between the states of matter, the phase changes, in relation to temperature and adding or removing energy over time. So when it comes to the phase diagrams, we are going to be specifically talking about the relationship between temperature and pressure and how those two variables can be used to control the phase of a particular substance. Now, as stated here on the screen, a phase diagram shows in which of the phases a substance exists and how the different conditions of a temperature and pressure can affect it. So with that idea in mind, let's go a little bit more into it. So the phase diagram is going to have three regions. The obvious three regions are going to be the different states of matter, so solid, liquid, gas. And there's going to be three different regions that are going to have their individual curves, and each of them is going to be separated. And I'll show you guys in a moment an example of what one will look like, but then we're also going to draw one together. Now, the points that are shown on the curves indicate the conditions under which two of those phases exist. And that'll make more sense once you actually look at the phase diagram. But just know that the curves that are on the phase diagram represent the equilibrium. So specifically the phase change. So here on screen, you have an example of a phase diagram. So as I was saying, we have the three different regions. So we have our solid, we have our liquid, and we have our gas. Now, something important is that the lines that are separating the different states of matter, those lines right there is what represents the equilibrium. So normally we like to think that there is just one melting point and one freezing point. Well, that is true, but it's dependent on the pressure. So when we say the melting point and the boiling point of a substance, we really are talking about at a specific pressure. So if we were to change the pressure, then we would have a slightly different melting point and boiling point. So just know that any point along the line is melting and it is freezing. Vaporization, condensation, sublimation, deposition. Of course, it depends on which of the lines you're talking about and which one you're focusing on. So let's go ahead and draw one together. I'll give you more information about really what everything is being represented, and I'll give you a little bit of more definitions that can go along with this. So on a separate sheet of paper, you should be able to just draw your X and your Y axis. So that's what I'm going to do here, X and Y axis. Now, as in our previous visual, we are going to have the pressure, and we are going to have the pressure specifically in atmospheres, ATM. This is units for it. Now, on the bottom, we are going to have temperature. And sometimes you will see degrees Celsius or you will see kelvins. So those are just two of the units that we utilize for temperature. So again, you can see one or the other. Now, within our graph, we are going to just draw a slightly kind of straight line, but curved at the same time. And after that, we are going to then do a curve that goes all the way up. And then also not at the same slope as that original line that we drew, but kind of slanted. So with the still straight, but with the slight slope. Okay, so now that we have the three different sections, we are going to label them the three different states of matter. So we are going to have solid, we are going to have liquid, and we are going to have gas. And as in our previous video, I'm not going to draw it on here on this one, just because it can get very busy and writing on the screen is a little bit difficult. But I do want to show you guys the different arrows that you would see. So, and I'm just going to name them. You can write them as I say them. But when we go from solid to liquid, we are going to have the melting phase. And that is every single point that falls on this line between solid and liquid represents melting. that equilibrium between solid and liquid. When we go backwards, so we are doing an exothermic reaction. When we go from liquid to solid, we have freezing. And again, every single point that falls on that line that separates solid and liquid represents the freezing point at different temperatures and pressure. Now, when we go from liquid to gas, we are going to have our vaporization. When we go backwards, so exothermic is going to be condensation. Now here at the bottom, we're going to have from solid to gas, that's going to be sublimation, and backwards is going to be deposition. So again, I'm not going to write it down the names of the phase changes simply because it can get busy and I don't want to overwhelm the screen. Now, something else that is important that we need to draw is right here in this section where all three lines meet, so where they intersect. That right there we call the triple point. And I'll give you guys a definition in just a moment. But from the name, you can kind of see that it's going to involve all three of the states of matter. Now, all the way at the top when we have our gas and our liquid, that ending of that line, that's important, that we call the critical point. Now, the critical point is, and I'll give you guys a definition, but the critical point is wherever we see that temperature where we no longer have a liquid, we have a gas. And that's really at that point, after that, we reach that temperature, liquids don't truly exist anymore, despite of the pressure, it just stays as a gas. Now, I mentioned earlier in the video that when we talk about the melting point and the boiling point, well, that depends on the pressure that is being applied onto this particular substance. But we still have to have a melting point and a boiling point that can be considered kind of like the standard. And there is. That is based on the idea that there has to be indeed a standard. And the standard, I'm going to write it here on the side. You don't have to include that necessarily. You'll see it on the next slide. But the standard value for pressure is 1 atmosphere, so 1 atm. This is what we call the normal. So I'm going to just, we're not being very specific, right? We're creating a generic version of our graph. So what I'm going to do is I'm just going to, right here, I'm going to write here, between the critical point and the triple point, I'm going to write a 1. So 1 atmosphere. And that is what is considered to be the standard, the normal. So wherever your graph, your phase diagram intersects that line, and I know my video here, it's not going to be perfect, but try and draw it as straight as possible. Wherever that 1 atmosphere, so the standard, meets the line of equilibrium between solid and liquid, that point right there becomes, it's going to get really messy right now, but that point right there we call the normal melting / freezing point. So I'm just going to write melting point. Wherever the line intersects the equilibrium point between liquid and gas, that entire line that is kind of curved, that is going to be the normal boiling point. Now, again, when you are looking for the melting point and the boiling point online, usually that's what you're given, the normal. We just don't necessarily call it normal, but that is exactly what it is on this graph. And again, that always is going to happen. It's going to take place in the intersection between solid and liquid at 1 atmosphere. So what happens if the 1 atmosphere happens to be lower, wherever we have the line between solid and gas? Well, that is going to be your, there's going to still be your normal point, okay? It just so happens to be between solid and gas. So at that point, we don't have a normal melting and a normal boiling point. Okay, so let's look at some of the definitions. This right here, what we have on screen is the phase diagram that we are going to be focusing in this class. Again, this is a generic one. We didn't really give values other than the 1 atmosphere because that's going to be the normal, the standard. But for the next couple of units that we're going to be talking about, the standard becomes extremely important, and we need to know how to identify it within a graph. So let's look at the definitions, and then we'll look at a quick example at the very end before we finish up our video. So for the phase diagrams, I already told you guys that the standard pressure line takes place at 1 atmosphere, so that's important to know, but we already have it labeled. Now, the normal freezing point, as I mentioned earlier, is that temperature at which the standard pressure is going to meet the solid-liquid curve. We already labeled that, and we did our little dashed line to make sure that they intersected. Now, the normal boiling point is going to be that temperature at which the standard pressure meets the liquid vapor curve. So where we have the liquid and gas intersecting with the 1 atmosphere. Now, the triple point, as I mentioned earlier, is that temperature and pressure at which all 3 phases, so like the 3 states of matter, solid, liquid, and gas, can coexist. So at that point, at that particular temperature and pressure, we will see evidence of solid, liquid, and gas states of matter of that particular substance. Now, the critical point is that one that's at very, very top of the curve, is the pressure and the temperature above which a substance can no longer exist as a liquid. So after we have reached the critical point, that specific pressure and the specific temperature, after that point, we only have a gas. We no longer have a liquid. Okay, so let's look at a quick example onto what it can potentially look like on our test and our quizzes. So what is going to be here, what we have on screen is the phase diagram for water. And it's already pre-labeled. You are expected to know how to label it from this point on. So a lot of the times you guys will see phase diagrams that don't have any labels other than the values on the X and the Y axis. So let's look at the first question. What is the state of matter at 60 degrees Celsius and 25 atmospheres? So this is just like in our algebra math classes where I give you a coordinate on the graph, you find it, and you give me the answer, right? So we are being told that we are at about 60 degrees Celsius. So I'm going to make my best guess here because this is not fully labeled, right? I'm going to say like 60 probably falls somewhere in there. And I am told that I'm comparing that with 25 atmospheres. So if we have 1 atmosphere here and 217 atmospheres there, I'm going to assume that 25 is going to happen like somewhere around here. So what is the state of matter? And that point of intersection is going to fall under the section for liquid. So my answer is going to be liquid. Now let's look at the next question. What would be the resulting state of matter if there is a drop in the temperature of 70 degrees Celsius? So here I am assuming then that the pressure stays the same. All I'm doing is dropping the temperature by 70 degrees. So if I know that my point occurred, the purple point, right, occurred at 60 degrees, and I'm going to drop 70 degrees, then I'm going to stay within my line, right, but I'm going to drop about 70. So that's going to be about -10. So I'm like right here. So what would be the resulting state of matter? Well, we went through our freezing point, right? Not the normal freezing point, because the normal freezing point occurs down here. But regardless, we went through freezing, right? Because we crossed that red line, and we ended up in the solid. So the resulting state of matter is going to be a solid. Now, from this point on, a lot of the questions, we have to be very careful. We have to look at the words that they're using. We have to be also attentive as to whether we're being asked state of matter, phase change, if we're talking about the temperature or the pressure. So we have to be very careful when we read those questions. On this video, like I said, we focused on the phase diagram. Later on, we're going to learn about the different calculations that are associated with both the heating curve and the phase diagrams, but that will be in later lessons.